So good morning everyone. It's afternoon already. Anyway, let's solve today's problem of the day. So what's the problem? You're given two strings, order and s. All the characters of order are unique and were sorted in some custom order previously. Remove the characters of s so that they match the order of that order was sorted. And more specifically, if a character x occurs before a character y in order, then x should occur before y in the permitted string. So basically, there is an order that you have to follow in the string you are returning as an answer, and that string should include all the characters of the string s, but the order of the characters of the string order should be same as it is already there in order. Also, here it is given that the orders, the characters of order are unique. So again, unique is written in bold. You can think of maps and sets here. No matter what, maybe hash map in C++, an ordered set or an ordered map, or map and set. What's the difference? The internal working is different. An ordered set and map uses hashing internally, and map and set uses binary search trees. Well, the unordered set and map are a little faster than map and set. You should keep it in mind. So, if you write map here, then your solution might be a little less faster than unordered map. Anyway, firstly let's take a string answer. We'll add to it. Then let's take an unordered map, an unordered map char, and we'll count the frequency of the characters. The approach is firstly we will iterate through the string s, and we'll store the frequency of each character. Suppose in the question, the first example, in order is C, B, A, and S is A, B, C, D. So we will be iterating over A, B, C, D, and we'll put that A comes once, B comes once, C comes once, D comes once. Maybe they might appear more than once. Next, we will run through order and check. The first element of order is C. Now, is there C in S? So we will be searching whether C is present in S or not. And since we are using map, the search operations will cost us only constant time. That is the BO of 1. So we'll check C, then B, then A. If they are present in S, we will add to the answer. If they are not present, we will not add. After we are done with iterating through order, then we will add the rest elements of S to the answer. How we'll do it? Let's see. Let's name it store. Now, for int I equal to 0, I less than s dot length I plus plus will store the frequency as it. So if it comes first time, it will be 1. If it comes again, it will be 2. The frequency of character. They are key value pairs, right? So after we are done inserting the values, now let's iterate through order. For int I equal to 0, I less than order dot length I plus plus I plus plus. So what we'll do is we'll check if we have found this element in store, and the way to find is the find function. If we find order of I, store dot and wait, I haven't written it yet. So what we are writing here, if we find the order of I, we are finding the keys here. If we find a character inside that map, that is, the find function is not returning to the end pointer, which means that it is not found, then we will add it to the answer. Answer plus equal s of I, sorry, order of I. Now, in these examples, C, D, A, and the S is containing A, B, C, D. What if the characters which are uniquely present in order are present more than once in S? And the first time I wrote the solution, I did not consider that. So there was a test case where suppose C, B, A, right? Then S has A, B, C, C, D. So since C comes in the at the first place in order, you have to put all the C's of the answer at the first place. After that, you move on to the next element. So for that, now what we have is we have the frequency of order of we have the frequency inside store, right? So what we'll do is, while if we found, so if we found, then we'll check, we'll run this loop till the frequency is greater than 0. We'll increase answer, we'll add answer, that element to the answer string, and then we have to reduce the frequency as well. How do you reduce it? Simple. Store of order of I minus minus. Now we have to repeat this step again. We're done with the for loop, right? Yes, we're done with the for loop here. Now the order of the elements in the order string has been maintained and they are already added to the answer. Now the rest elements of S has to be added, and it's not important in what order they are added. So add it randomly. What we'll do is, all those elements are already there inside the store. For auto X in store, but we cannot randomly add it. We have to check whether their frequency is more than 0 or not, because the keys will always be there. We haven't deleted the keys. We could delete that keys as well, but we can check it like this as well. So if x dot second, that is the frequency, is greater than 0, so that means there is a key with frequency greater than 0. We have to add those. So we'll add until the frequency is not 0, until the frequency is 0. While x dot second is greater than 0, answer plus equal to x dot first. We are adding the character, the key value pair. The key was the character, value was the frequency, and then we have to reduce the frequency, minus minus. If we return answer here, let's see, it might be better. It's working. It's adding 5 ms. The first time I wrote it was 0 ms. See how the time is varying. It's 0 ms now for the same test cases. 3 ms beats 50%. If I submit it again, 100%. And you guys know that these factors doesn't matter. They are variable. They change. See, 0 ms, 100%. The same solution. So don't focus too much on how much percentage of users your solution is beating. Just focus on the learning. So goodbye for now.